Alrighty then, corn children. It is the highly anticipated Geometric Sequences Part 2 video. Woo! If you haven't watched Part 1, well, guess what? Go do that. Alright, so let's have a look at this. Here we are, and I have given you a sequence, 1,000, 1,200, 1,440, and so on and so on and so on. First thing we want to know, is it geometric? Now, unlike some of the previous examples, it's not as obvious that it's geometric. So, if we want to know if it's geometric, what we're asking is there a number that we have multiplied by each time? Once again, R has a name for a reason. It is the geometric ratio. So we're going to, the common ratio. So we're going to form a ratio. What do you mean? I'm going to take any two consecutive terms, and I will take the second of the two and put it over the first of the two. And we can divide those. This, ladies and gentlemen, is a ratio. As it turns out, it doesn't even matter. You could have taken the third and the second. Yes. Yes, you could. And each and every time, divide those on your calculator, you get 1.2. Yeah, so here's what this is saying, and you can check it out. To get from here to here, I've multiplied by 1.2. I've multiplied by 1.2. Guess what I did? I multiplied by 1.2. So the answer is, yes, it is geometric, and we have the R value. Now, from video number 1, part 1, we recall that the explicit formula is A1 R to the n minus 1. So if we want to write the explicit formula for this sequence, we need to fill in this A1, this R, and the variable is n. It's a formula. If you want the first term, put in a 1. If you want the third term, put in a 3. I've asked you down here for the 10th term. So we are asking what is the 10th term is saying, what is a sub 10? Yeah. Now, if you're smarter than the average bear, you can figure out that 10 minus 1 is 9, which will make it a lot easier to type in. And we're going to get the answer. Now, because of the decimal point, the 10th term has a lot of digits. Now, you could give me just 3 accurate decimal places, and this actually continues further on, but that's what it is. You should take the time to type that in, do it yourself, pause the video, and so on and so forth. Okay, that was fun. Awesome. Now, what could be even more fun? Well, taking a geometric sequence and adding up some of the terms, like the first 4, or the first 5, or the first 70, or whatever. That makes a geometric sequence a geometric series. So again, the word series implying partial sums. All right, don't worry about that so much. All right, so what's the formula? Well, here it is, people. Here's your geometric series formula. You're going to want to write that down. S for the sum, sub n, meaning the first n terms. A1 is the first term. That's the number 1. That is the common ratio raised to the nth power over 1 minus the common ratio. Now, in our textbook, they have this flipped around. That's fine. It's still true. I prefer this version, and there's a reason. I'm not going to tell you what it is, though. You'll have to watch a coming soon video to get the reason. Hey, be careful here. Do you see this n? It is not outside the parenthesis. It is inside the parenthesis. If it was outside the parenthesis, we could cancel. Here it's inside the parenthesis, no canceling. Got it? Awesome. Let's kick it around. Let's try it out, shall we? On what, you ask? On this question. Find the sum of the first, I changed my mind, 15 terms in this particular sequence. Okay. All right, so we're going to find the sum. Well, first of all, if we're going to use this geometric series formula, we better make sure this is geometric. Yeah, I know. So here's what we're going to need to do. We're going to have to see if there's an R value. So just like we did in the previous example, we can take any two terms. I'm doing the second term and dividing it by the first term, and we form a ratio. And out pops 1/2. Now listen, that does not guarantee it's geometric. You then would have to check to get from here to here. I multiplied by 1/2, that's what this is saying, but does it work here? Does it also work here? You need to check these things. Just because the first two numbers form a ratio doesn't mean it works consecutively each term. In this case it does, but you're supposed to check that. Yeah, I know, check your work. That's crazy. All right, it is geometric. That is our R value. I've checked. So, to find the sum, all we have to do is fill in the stuff. 15 terms. A sub 1 is the first number. Did I write it down right? Yes, I did. 1 minus. Now, it's easier to use the decimal here, I believe, unless you want to use your fraction maker. So I'm just converting R to 0.5, and there are 15 terms. N is 15. And we're going to put that over 1 minus 0.5. Can I suggest / command that in order to do these, you really might want to work with your fraction maker? What? You remember this? The green alpha key? And the F1 shortcut key? And the first one up is N over D. I hit enter on number 1, and it makes a fraction. It just prevents you from having to put in a bunch of parentheses. Now, if you have a TI-83, sucks to be you, you're going to need to put in all the parentheses. All right, so all you have to do is type this in. When you type this in, and yes, you should type it in. Practice doing this. That's what I got, so hopefully that's correct. Awesome. Now that's not bad. That's straight plug and chug. You just take the numbers, plug them in, crank out the answer. This next example is much more difficult. And if you need to, you can go back to Geometric Series and Sequences Part 1 and do another example that's going to help with this. All right, we're supposed to find the sum of this sequence. 2, 6, 8, 15, yada, 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 all the way to this giant number. Now, I'm pretty sure you all have realized that the R value is 3. Awesome. So that's pretty easy. The first term is very easy. It's right here. But here's the difficulty. N is saying, how many numbers did you add up? This is the first, the second, the third, the fourth. But because of the yada, yada, yada here in the middle, we don't know how many terms we have. So the N is an unknown at this point. I'm putting a little box where the N needs to go. We don't know what N is. We don't know how many terms we're adding up. So we actually need to find N. All right, let's be clear. If there were 30 numbers here, this is the 30th number. If there were 15 numbers, this is the 15th number. If there are 8 numbers, this is the 8th number. So if there are n numbers, this is the nth number, a sub n. Is that making sense? Hopefully it is, because we're going to need to use that to find n. We are going to use the explicit formula to solve for that n. Okay, so again, if there are 30 terms, there aren't. But if there were 30 terms, this would be a sub 30. So if there are n terms, this is a sub n. This number goes on the left side of the equation. We know what a sub 1 is, it's a 2. We know what r is, it's the number we multiplied by. Now we just need to solve this. Campers, it is so important that you recognize that this 2 is not raised to the exponent. You must get rid of the 2 first. You need to divide by 2 first. When? First. Now I've already done that math, and again, hopefully I did that correctly. And we get here. Well, now what? How do we get a variable, an exponent, out of, or the variable, the x or the n, out of the exponent? Logarithms. I'm going to take the log of both sides. I'm using natural log. You can use common log. If you have the log base button, you can do log base 3. I'm using natural log. Why? Why? Because there are laws with logarithms. And one of the laws says that this exponent can come in front out of the exponent as a coefficient. And that's just multiply now. So if you want to solve for n, you just divide. To get the n alone, you add 1. Again, use your fraction maker. It makes your life easier. You type this into your calculator, and n is 15. This is apparently the 15th number. This is a sub 15. There are 15 numbers, so I can take that 15 and drop it in here. Well, now we just type this in. To find the sum of the first 15 terms, we type like we mean it, and we get that number. Hey, do that on your own with your own calculator. I dare ya.